Hello and thanks for watching Gary Teaches Maths. I'm continuing to go through the Edexcel higher tier paper from 2008, and this is paper 1, the non-calculator paper, and I'm on question 20, which is a question about inequalities. So we can see we've got two inequalities here. We've got 3n plus 2 is less than or equal to 14, and this other one, which is a non-linear inequality, which is that 6n over n squared plus 5 is actually greater than 1. So we've got to find all the possible values of n, and it's all the integer values of n, which means all the whole number values that n can be. So if we turn our attention first of all to the linear one, 3n plus 2 is less than or equal to 14, we'll just treat that like an equation. So we say 3n plus 2 less than or equal to 14. I'm going to take away 2 from both sides, so I'll get 3n is less than or equal to 12, and then I can then divide through by 3, divide both sides by 3, so I'd end up with n is less than or equal to 12 divided by 3 is 4. So we're looking for an integer from the first one that's less than or equal to 4. But we also, in order to not have an infinite number of values, as we could see from this one, could have an infinite number of negative values which are less than 4. And we've got to solve this nonlinear one with the squared in it. So we take the 6n over n squared plus 5, and that's greater than 1. And what I'm going to do first of all is get this squared part plus the 5 out of the denominator, and I'm going to multiply both sides by n squared plus 5. So I'd end up with, if I do that, the n squared plus 5 will disappear on the left hand side, leaving me with just 6n, and it will be multiplied by the 1 on the right hand side. Now see, if I multiply just by the 1, I'm just going to get this n squared plus 5 here, so I'll get n squared plus 5, because 1 times anything is just itself. The next thing I'm going to do, this is looking a bit like a quadratic now, and I'm going to take away 6n from both sides so that it's equal to 0, which is the way that we usually solve quadratic equations, by making them equal to 0. So that will give me a 0 on the left hand side, and that will be equal to n squared minus the 6n plus the 5. And it looks a lot nicer if I write this bit on the left hand side, and then I'd have to change the order of the inequality. So I'll end up with n squared minus 6n plus 5 is going to be less than 0. So that's our second inequality that we've got to solve. The way we would do that is, first of all, let's try and just imagine it was an equation equal to 0. So we're going to find the solutions to n squared minus 6n plus 5 equals 0. We're going to do that first. And if we do that, this is just like a normal quadratic, we're going to put it into two brackets. We'll get n at the start of each bracket, and we're looking for a number that will multiply to make 5, and we'll add to make minus 6. And we can see that that's actually minus 5 and minus 1. So the solutions to this one then would be n equals 5 and n is equal to 1. And if we were to draw the graph of the function of n, it sounds a bit complicated to put it like that, but if I draw the graph of y is equal to a function of n, which is the n squared minus 6n plus 5, it would have the normal quadratic shape, which is a U shape. And so if on an axis, it would look like this. Because we found these roots, we know it would go through at 1 and 5, because these are the values where it would be 0. Because that's what we did there, we made it equal to 0. And that tells me that this quadratic shape, which all quadratics look like this, but they're just moved around, They're either a little bit steeper or moved up or down, but they're still always basically the same shape as an x squared graph. So this is what it would look like if we drew this function of n. And we're interested in, where is it less than 0? Well, it's less than 0 between 1 and 5. So we can say, so the values of n that we're interested in that would solve this inequality, this one actually, going right back here, which we then put into this format, are when n is between, not outside, but between 1 and 5. So n would have to be greater than 1, and n would have to be less than 5 to solve our second inequality. Now, we're actually looking for all the possible values that satisfy both of these two ranges of values. And we can see that, in fact, this value here cuts this top value off here. So, in fact, combining the two inequalities, we get the bottom value of 1, but then because this one is lower than the 5, the upper value is that it's less than or equal to 4. So this is what both inequalities together give us. And then we're told that n is an integer, so a whole number. So we're looking for whole number values which satisfy this inequality. So that means n can't actually equal 1. So the lowest value that n could be would be 2. 3 is a whole number which is in that range as well. And because it's less than or equal to 4, it can actually be equal to 4. So these are the values, the acceptable values for which n is an integer and both of these inequalities are satisfied. So that's it, we've done it. So I hope that's been helpful to you. If it has, please like our video and subscribe to our channel. And for more help, look at our website, which should be just appearing at the top now, which is bestmathstutors.co.uk. Thanks for watching.